3-3, the addition rule is what they've called it. Basically, now it's not necessarily independent and dependent anymore. We're going to say, are they mutually exclusive? That's kind of just weird words. Mutually meaning they kind of both agree, all right? Exclusive, though, it comes from exclude, okay? So in other words, really what that's saying, it's a pretty short one, actually. Whoops. Events that cannot occur at the same time. What's probably a good example of that? Well, our first example here is a great example of that. It says rolling a 3 and rolling a 4. Can you do that at the same time if you only have one number cube? It says roll a die on this first example. Can you do that at the same time with only one die? No. So are they mutually exclusive if it's an event that cannot occur at the same time? Yes, that's what it means. So these cannot occur at the same time. So yes, that is mutually exclusive. Again, if you want to write down because they can occur at the same time, well, maybe that'll help you remember. Can't occur at the same time. Now, what if I change it to rolling 2 die? Can you roll a 3 and a 4 then? Yeah, then you can. But if I'm only rolling a die, or number cube, it's impossible to do that at the same time. Okay. How about, so here it says selecting a student. So event A is selecting a male student, and event B is selecting a nursing major. Can you do that at the same time? You can, can't you? This is kind of going against your normal thought patterns that many of you are going to think the nursing student has to be female, right? Well, that's not the case. There are many male nurses out there. So can you actually select those at the same time? You can. So are they mutually exclusive? No, they're not, because it can actually happen at the same time. And how about event A down here for number 3 is that a donor's blood type is O and that the donor is female. Can that happen at the same time? Yeah. Now, if what I said the donor's blood type is O and the donor's blood type is A, well, that's not going to happen, right? But O and female, that can happen at the same time. So no, they are not mutually exclusive. And as you've noticed, whenever we've made a very big distinction in any of these vocabulary words, it's because if you know this information, it can save you some time, all right, in your calculations. And that's why we make these distinctions. Okay? And because here's the addition rule. It says the probability that events A or B will occur, not and, but or. So A or B will occur, so it's kind of written that way, A or B, you probably knew that, is given by, well, right here. You have to take the probability of A, add the probability of B, and subtract the probability of them both happening at the same time. Okay? Now some of you are saying, how's that going to work? Well, you'll see in a few examples that we do. But if you know they are mutually exclusive, for example, back in that last one, rolling a 3 or a 4, right? Because they are mutually exclusive. Again, rolling one or the other, well, then I can just use this one down here and just add the two together because they can't happen at the same time. Why would you subtract basically 0? Right? Because they can't happen at the same time. But that's why some people just use this formula and just put a 0 in there every time. Okay? Because then they don't have to remember 2 formulas. That's completely up to you. So first, let's kind of find out. So you select a card from a standard deck. Find the probability that the card is a 4 or an ace. So basically, can that happen at the same time if you're only picking one card? No. So you could narrow it down to this second equation here, or you could just say, well, you know what, let's just kind of go through the formula. So it's 4 or ace, and you can kind of abbreviate however you need to in your problems, right? So according to our formula, we would find the probability of getting a 4. We would add the probability of getting, whoa, there we go, an ace, and subtract the probability of a 4 and an ace. Because here's kind of how I look at it. It's completely up to you which formula you want to use. But I like to just remember kind of 1. So the probability of a 4 or an ace is, well, what's the probability of just a 4? 4 to 52, right? You agree with that? Now, we're not saying we picked a card, put it back, and all this stuff. We're just saying a completely separate possibility. Let's say all I wanted to do was pick an ace. Probability of getting an ace is 4 out of 52, right? And then subtract the probability of getting both. Well, if you're only picking one card, the probability of getting both is 0 out of 52, right? In other words, 0. And that's why in this formula here, they're basically saying you don't need that if you know they're mutually exclusive, because it's not. It's always going to be 0. Okay? And so if you add those two together, at this point, would it be probably a good idea to simplify? Because we didn't know what was going to come here, that 0. We weren't sure, right? And so that's why I wouldn't simplify right off the bat. But you might want to now. It's the same thing as saying 1 out of 13, right? Do you agree with that? Is that how it works out? Yeah. And 1 out of 13, are you in agreement with my simplifying here? Okay. So in other words, 2 out of 13. So not the greatest. What is that? 0.154 is about what I got here. So they're saying, does that make sense to you that if you went to a standard deck of cards and you wanted to get a 4 or an ace, that you would be able to do that about 15% of the time? Get a 4 or an ace if you just pick one without looking? That's believable, isn't it? I mean, if I would have said 50%, then you'd be like, wait a minute. I don't know, it might be a weird deck of cards you got there. All right. But that does make sense. Okay. So do you see how the or works? You want one or the other, not and. You don't want them both to happen, just one of them. Okay. So you roll a die. Find the probability of rolling a number less than 3 or rolling an odd number. Can that happen at the same time? Can you get both of those? You can, can't you? Okay, when can that happen? Of rolling a number less than 3 and rolling an odd number. When does that? When you roll a 1, right? So, uh-oh, we have a problem here. So this one's also harder to abbreviate, but so probably what? Well, we can get tricky though. Less than 3, right? Because you could write it out if you want, but I'm a mathematician. I don't want to do that. Or, okay, yes, a disconnected part, yeah. Or odd, right? So you're going to take the probability of less than 3, figure out what that is. You're going to add the probability of being odd, and then you have to subtract out the probability of being both. Because again, they're not mutually exclusive, and so we have to have that last part in there for sure. So, what's the probability of less than 3? What are our options here? Maybe we'll do it down over here. We could roll a 1, right? We could roll a 2. Can we roll a 3 according to this wording here? How about a 4, 5, 6? Is that what we want? No. So how many options do we have here? There's 2 out of how many total options? 6, right? Yeah, it's okay. He's on the other problem. That's okay. He's still thinking. So do you agree that it's 2 out of 6? Once again, should I reduce yet? I mean, because is there a possibility that a 6 is going to show up again in this problem? There is, isn't there? And are we guaranteed we'll be able to reduce? Not really. So maybe we'll just wait on that. 2/6 plus. How about getting an odd? Well, we could roll, if we're doing odd, let's maybe do that one over here. We could roll a 1. Just for an odd, can I roll a 3? Yep. I'm just saying just for an odd, right? And we can roll a 5. We're just doing the odd part. Right? So options we have 3 out of a total. The sample space has how many options? Has 6, right? So in other words, 3 out of 6. Again, we could simplify both of those, right? But we really don't know what we're going to come up with. And if we simplify both of them, we have different denominators, which isn't a good idea then, right? So now we have to subtract. Well, let's take a look at these two. So you notice how I put the sample spaces down so we could look at them. Do they share anything? Can I have, it both happen at the same time? I can, because they both have. And is that the only thing? Is that the only way that both of those could happen at the same time? So that only has 1, right? So minus 1 out of still, the sample space still has how many though? Still has 6, right? Options, right? 1, 2, 3, 4, 5, 6. And so now you see why a lot of times I wait to simplify. Because you never know, what you're going to have to add, subtract, whatever. So we got 2 plus 3 is 5. Minus that is what, 4? Out of 6, otherwise known as 2/3, which is about what, 66.7%, we'll say. Do you agree with that one? Again, I always want you to check feasibility. So I roll a die, I want to either get something. So let's face it, I can get, if I want one or the other to happen, I can get a 1, a 2, a 3, or a 5, right? Does that sound about right? Yeah, that's probably going to happen quite a bit, isn't it? Very feasible. Now, if you would have said 6%, yeah, that doesn't make sense here. 6% chance. But 66, that does. Okay. So any questions on mutually exclusive? I know it's kind of a weird word, all right, or words, but basically, can't happen at the same time. So a blood bank catalogs the type of blood, including positive or negative Rh factor. given by donors during the last 5 days. So apparently this is a pretty big one, if this was just the last 5 days. The number of donors who gave each blood type is listed, and a donor is selected at random. Is that kind of important, that it was at random? Yeah, it is. All right. So determine the probability that the donor has type O or type A blood. Well, if you write that out, it'd be probability of O or A, right? Can they happen at the same time? No. So these are mutually exclusive, correct? So I don't have to have that last part on there, but again, I might put it on there just so we can say minus. Well, what's the chance they happen together? 0. Okay, so that's kind of how I like to look at it. The probability of O plus the probability of A minus the, ooh, that's a good minus. Minus the probability of them happening at the same time, which we already know. So what is the probability of having O? Well, let's go where it has O in a column here. And it looks like we got a 156 in that column. We got a 28. So a total for O is 184. Do you agree with that? So it's right here, right? Total of O. So we've got a 184. Oh, that's a bad 8, but you get the idea. Out of what, though? Why 409? Yeah, that's the total of everything over here, right? So out of 409. Plus. I like some of these blood type problems because it gets you into something that you're not used to. When you do probability, you're used to the die, the cards, and all that stuff. It gets you to look at things differently. That's why I like these. How about A then? We'll color code it here. A, well, A is what? 164, right? Is it still out of the 409? Because we're saying or, right? We're not saying both happen, right? And then minus, of course, well, they can't happen at the same time, right? So 0 out of 409. So we're going to have to add those up there. 348. 348 over. So in other words, pretty good chance or pretty small chance? Pretty good. I think it's about 85%. 0.1. Approximately. And if you look at the data, that supports that. And that's where most of the people are, right? Why don't you try number 2 on your own? See what you can come up with. Well, what did you come up with here? Probability that the donor has type B blood or is Rh negative. Mutually exclusive? No. Okay, because they can actually happen at the same time, can't they? All right. And so, again, it's kind of harder to abbreviate this one. So probability of what, B? Or Rh, what is it, negative? Okay. So we got to find the probability of B. And we got to add the probability of Rh negative and subtract the probability of them happening at the same time. So what'd you get for probability of B? Well, let's get this other stuff out of here. Is the total still 409 as it was in the first one? Yeah, it's still 409. So probability, where's B? Well, B in that is just total for 45, right? How about Rh negative? Where's that? Well, here's negative, right? So where's the total for Rh negative? Well, way over there, right? 65. Yeah, so 65 out of 409 minus, well, where do you find this answer? What do you mean where they come to? What two things come together? Yeah, so negative crosses with B is right here, right? So there's 8 times that it happened at the same time. Okay, so we got to get that out of there. So subtract 8. It is still out of 409. Okay. And so what do we got there? 110 minus 8 is 102. Out of 409, what did I put the percent there? About 24.9 I got. Is that believable? Based on the numbers. And just based on general knowledge of blood types. Yeah. And didn't we say yesterday AB was the most rare? And so that actually, because this actually is data from somewhere. Okay. So yeah. Okay. So any questions on mutually exclusive or how you have to deal with it or why you even care? let's face it, could you do one of these problems without knowing if they're mutually exclusive or not? Well, yeah, you would just get to this bottom part and subtract maybe something and maybe not. If you subtract, what number do you know that they'll be mutually exclusive? If you subtract 0, then you know that they couldn't happen at the same time. Okay? Nothing? All right.